Today's main focus, trigonometry. Lesson 101, mathematics. Let us start. Trigonometry is the study of the relationship between the sides and angles of triangles. Trigonometry means measurement of triangles. What is important is to know the trigonometric ratios. Basically, we have 3, but we can expand those 3 into 6. So the first trigonometric ratio is sine. It's a trigonometric ratio which goes hand in hand with an angle. We represent angle using the symbol theta, or we may use alpha, gamma, omega. The second trigonometric ratio is cos theta, and then lastly we have tan theta. We normally use these ratios to determine sides and angles of a triangle. Now each trigonometric ratio, it has an expression. The expression of sine is opposite over hypotenuse, height. You simply write this down. We are going to explain this further. And then for this one, it's adjacent over height. For this one, it's opposite over adjacent. Simply write these ratios and their expressions, and then we are going to explain them in detail. Suppose we have this right-angled triangle, and then we need to explain or express our 3 trig ratios. Before we can do that, we need to determine the sides with respect to one of these 2 or 3 angles. Now what we need to know, or what we know, is that a right-angled triangle, one of the properties, it has 90 degrees. So we normally represent 90 degrees with this symbol. One of the interior angles is theta, and then the other one is alpha. Now looking at the right angle triangle, we can see that the opposite side is always the longest side. The opposite side of right angle triangle is always the longest side. The longest side, we always call it hypotenuse. The longest side is always hypotenuse. And then in order for us to determine the hypotenuse, we always use the longest, not the longest, actually the right angle triangle. Now if we focus on theta, the opposite side of theta, we call it side opposite. Since we know the hypotenuse, we know the opposite, it means this side will be our adjacent side. Now suppose we focus on angle alpha. Our hypotenuse side will always be the longest side, whether we look at alpha or we look at theta. So this will remain our hypotenuse side even though we focus on alpha. And then this will no longer be the adjacent because it's opposite to alpha. So for alpha, this will be the opposite side, and then this one will be the adjacent side of alpha. I hope you can see this. Now let us look at the applications of these 3 trig ratios. The question, we need to express these trig ratios using this diagram. Now to analyze the diagram, we can see that this is our 90 degrees, so this will be our height. And then looking at beta, this is the opposite side of beta, then this will be the adjacent of beta. Looking at alpha, this will be the opposite of alpha, this will be the adjacent of alpha. So we need to express these trig ratios using M and P. The first one is sine alpha. Sine alpha says opposite over hypotenuse. That is the expression. It's opposite over hypotenuse. So what is our opposite side in this case? Our opposite side of alpha is mn. So it will be mn over the hypotenuse is mp. Going to sine beta. Now we focus on this one. The expression of sine, it's still opposite over hyp. So sine beta it's equals to the opposite side of beta is np, hypotenuse it's still mp. Now we move on to tan beta. Remember the expression of tan is adjacent. So what is the adjacent side of beta? It's this, the opposite is this. So tan beta it's equals to np over mn. Remember the opposite and the adjacent. Cos alpha. Looking at alpha, the expression for cos is adjacent over hypotenuse. So we have np. Since this is alpha, the adjacent side of alpha is np. So we have np over the hypotenuse, it's mp. It's mp. So these are the basics application of trig ratios. Now let us look at how to actually apply this basics and solve for unknown variables. In this case, you are given this right angle triangle, and then the question, calculate the value of theta. Now we need to analyze first and choose the suitable trig ratio. This is theta. We can see that we don't have the opposite side. We have the adjacent and the hypotenuse. Since this is our 90 degrees, so this will be the hypotenuse. Now we need to use a trig ratio which involves the two given sides, and then we will be able to calculate our angle. Since we have the adjacent and the hypotenuse, we know that the only trig ratio which involves the adjacent side and the hypotenuse is cos. So we are going to use cos theta in this particular question. Now cos theta is equals to the adjacent side, in this case it's 12 over the hypotenuse is 13. Now we need to solve for theta, so it will be angle is equals to the cos inverse. If you don't know how to actually punch this on the calculator, simply click shift cos and then something like this will appear, and then you put this number here. Theta is equals to 22.6 degrees. So this is the value of theta. Round off to 1 decimal places. Let us look at more examples. Go ahead and pause the video, work out the question, play the video, and verify your answer. Now, looking at this is our 90 degrees. The hypotenuse, we don't have anything. Now, this is the theta. Remember the question, we are still calculating the value of theta. We can see we have the opposite side and the adjacent. Since you don't have the hypotenuse side, so it means all the trig ratios which involves the hypotenuse side, we cannot use them, such as cos theta and tan theta. Actually, cos theta and sin theta. The only trig ratio which involves the opposite side and the adjacent is tan theta. So we are going to use it. Tan theta is equals to, the opposite side of theta is 4/1/3. Then we are going to have tan inverse 4/1/3. This is the answer. I hope you got it correct. Let us look at more examples. You should be able to work with right angle triangle even though it is orientated in different ways. You should be able to identify all the sides. Now in this case, we can see that we have the hypotenuse. Since this is 90 degrees, the opposite side is there, and then the opposite side of theta, we don't have it, and then we have the adjacent. So we look for the trig ratio which involves the adjacent side and the hypotenuse, and then that trig ratio is cos, so it's adjacent over hyp. Then we have cos theta is equals to the adjacent side is 4.4/11. Inverse 4.4/11. The answer you should get 66.4 degrees. I hope you got it correct. This question is a bit different, but we are still using those three trig ratios. This one is solve for x, and then we are given one of the angles is 87 degrees, and then we can see our 90 degrees, and then we are given this side as 11. Now we need to analyze as usual. The opposite side of theta, we don't have it. We are looking for the longest side, which is hypotenuse. We are given the adjacent. So we need a trig ratio which involves the hypotenuse and the adjacent side. Since we are looking for the hypotenuse and then we are given the adjacent side, then we need this trig ratio. Cos the angle is 37. Where we see theta, we put the given angle. The adjacent side we are given as 11 all over x. Now we need to solve for x. So from here, we are trying to get rid of the fraction by multiplying each and every term by the term causing the fraction. In this case, you are going to multiply both sides by x. This will result into 1 multiplied by 11. This side we have 11. X multiplied by cos 37 is x cos 37. We want to remove cos 37 from x. We divide by cos 37 both sides. This will result into 1 multiplied by x, it's x is equals to, you simply punch this on the calculator, you get the value of x. Punching this on the calculator, we get the value of x as 18.77. round off to 2 decimal places. So you can see that the trig ratios, we can also use them to calculate one of the sides, or any side, when you are given enough information. We are solving for x. Let us analyze. The opposite side of the angle is there. We are looking for hypotenuse. We don't have the adjacent. The only trig ratio which involves the opposite and the hypotenuse is sine theta. The angle is 57 degrees. The opposite side is 10.8 over x. You multiply both sides by x. This will get rid of this, and then you have x. It's equals to 10.8 divided by sine 57. Our answer will be 12.88. Go ahead and pause the video, try to work out this question. Analyzing this question, we don't have the opposite. We are looking for the adjacent. We have the hypotenuse. So any trig ratio which involves adjacent and hypotenuse, it's cos. Cos 47. The adjacent side is x over hypotenuse is 3. Then remember, we are trying to get rid of the fraction. We multiply by 3, and then this will get rid of this. X is equals to, we simply punch this on the calculator. The answer is 2.05.